This call is now being recorded.
Respected Mr. Manoj Kumar Singh, Director Business Development, Isobar Energy, Kolkata, Dr. S.C. Chaube, Coordinator, TEQIP-III, RGPV Bhopal, Sri Shyam Rathore, Chairman, TRUBA Group of Institute, Bhopal, Dr. Rajiv Arya, Director, TRUBA Institute of Engineering and Information Technology, Bhopal, Professor Meha Srivastav, Head EC and EX Department and Coordinator of this event, faculty members, staff, and students from various RGPV accredited colleges. A hearty good morning to all. I, Mithilesh Gautam, Assistant Professor, Electrical and Electronics Engineering. TRUBA Group of Institute and co-coordinator of this event, feel privileged to welcome you all in the one-day webinar on Wind, a step towards sustainable energy for future generation, organized by TRUBA Institute of Engineering and Information Technology, in association with Rajiv Gandhi Pradyogiki Vishwavidyalaya TEQIP-III. TRUBA Group of Institute is well known name in the field of technical education from last 21 years. TRUBA Group always emphasizes on the enhancement of technical knowledge of the faculty members and students by organizing various workshops by the eminent speakers from industry as well as technical education. Following the legacy of lighting lamp in technical education, we are organizing this event today. Now, I would like to invite Dr. Rajiv Arya sir, Director, TRUBA Institute of Engineering and Information Technology, Bhopal, to deliver the welcome address.
Good morning, everyone.
Good morning, sir.
The speaker of today's event, Mr. Manoj Singh, Director Business Development, Isobar Energy, Kolkata, Head of various departments, faculty members, staff, and students of distinguished institutes. On behalf of TRUBA Group of Institute, I feel honored to welcome all our guests, faculty members, and students of distinguished institute for participating in this webinar on the topic Wind, a step towards sustainable energy for future generation. It's worth mentioning that this webinar is sponsored by RGPV under TEQIP-III. So I express my thanks to RGPV for sponsoring this program. As you all know that India is among top 5 countries which produces the wind electricity through wind energy. So this shows the relevance of this today's topic. Through this webinar, you can learn how wind energy is becoming one of the fastest growing source of clean energy in the globe today. What are its advantages, and even research efforts are aimed at addressing the challenges to a use of wind energy and the method to overcome it. Through this webinar, you can also learn how wind energy is becoming one of the fastest growing source of clean energy in the globe today. From an economic point of view, wind energy is very useful in driving growth. From social and environmental point of view, also it has proved well. The integration of renewable energy sources like wind and solar have shown their effectiveness in achieving an aforesaid target within the limits with the adoption and development of more advanced technologies, and have shown roadmap for their prospective growth. Today, you will become familiar how sustainable energy for all initiative is maturing and bearing fruits. It is the golden thread that links poverty eradication, equitable economic growth, and a healthy environment. So I extend my gratitude to our keynote speaker, Mr. Manoj Singh, Director Business Development, Isobar Energy, Kolkata. It's a great for our institute that you have accepted our request, sir, and taken out time of your busy schedule to guide our participants to give exposure on wind energy and its sustainability. I congratulate the organizing team for selecting such a relevant topic for the webinar. I hope that this webinar will definitely add value in academia, and the next few hours will be highly fruitful and knowledgeable for you. Thank you.
Thank you, sir. Now, wind power saw steady growth in India for about 3 decades. The country currently ranks fourth in the world in the wind power with 37.5 gigawatt of capacity installed, most of which was driven by incentives such as accelerated depreciation and generation-based payment and attractive feed-in tariffs. India has high wind energy potential, 300 gigawatt at 100-meter height and 695 gigawatt at 120-meter height. Nearly 97% of this potential is concentrated in 7 states: Gujarat, Karnataka, Maharashtra, Andhra Pradesh, Tamil Nadu, Rajasthan and Madhya Pradesh. Uh, our speaker for today's event, Mr. Manoj Kumar Singh, is visionary professional having 15 years of versatile experience in renewable energy and infrastructure sector. During his professional career, he has provided engineering, technical, policy, regulatory, commercial, project development, and asset management solution to more than 3 gigawatt of renewable energy assets in various parts of the world, including Albania, Nigeria, Thailand, China, Singapore, Germany, and India. He is community member of REN21 and contributed as an expert reviewer in yearly flagship report, Renewable Global Status Report 2018-20, Renewable Energy in Asia 2019 report, Renewables in Cities 2019 report, and Renewable Energy Policies in the Time of Transition 2018 report. Mr. Manoj is also active member of Indian Wind Power Association and Renewable Energy Welfare Society. He has provided policy and regulatory inputs to Ministry of Renewable Energy, Ministry of Power, and various government bodies for forming offshore wind policies, wind solar hybrid policies, Indian Electricity Act 2020, National Wind Policy, and Mini Grid Policy. Key competency of Mr. Manoj are policy and technical advisory, regulatory studies, due diligence, feasibility study, team building, business development, long-term strategy development, risk and contact management, project development, program management, and project execution. Mr. Manoj Kumar Singh is currently working as Director Business Development, Isobar Energy Kolkata. So without any delay, I would like to invite Mr. Manoj sir to start today's session. Manoj sir, please.
Yeah, good morning everyone. Thanks Niklesh for introducing myself. It's a good to, actually I just wanted to tell you I am also part of Rajiv Gandhi Vishwavidyalaya. So I also did my engineering from RGPV only in 2005. So it's good to connected, with the same university people and faculties. And it's my privilege to, given me chance and to give you insights of what is happening in the wind energy sector. So just yeah, is it visible now?
Yes, sir, it is visual.
Yeah. So today our topic is wind, a step towards long-term sustainable energy for new generation. Why we call this sustainable energy? Because the impact of this technology, wind technology, on people, planet, and business are positive. So that's why we call this as a sustainable energy, which will be there for long term and having positive impact on people, planet, environment, ecology, and as well as business. So that's why we call this sustainable solution. So today we will be covering first the fundamentals of wind power. Then we'll be looking what all project development and execution activities are there under this. Then we'll be also touching O&M and asset management. Then wind potential, as Mithlesh already told something about wind potential. So we'll be touching that points also. And what is the present wind power status globally as well as in India? And whatever innovations are happening in this sector. So one by one, we'll be touching these all topics during next 1 hour. So wind power fundamental. Basically, if we talk, so you can look at here various type of turbines are there. So how this turbines moves, what all science behind that wind turbines. So those aspects will be touching. So first, what is the origin of wind? So wind is basically the origin of this wind is basically solar energy and this Coriolis effect of Earth rotation. So these are the two major prime drivers of wind energy generation. If we talk about type of winds, so there are several type of winds: planetary wind, trade wind, westerlies, periodic. Under periodic, there are multiple winds are there. So in India, if we talk, mostly wind generation, wind power generation happens because of periodic winds, which happens during the monsoon period, and local winds are there also, responsible for wind generation in northern part of India. And these are basically the prime source of wind generation. And anemometer and wind vane are basically used for wind speed measurement and direction measurement. We talk about the basics. So fundamental equation of wind power, it's basically wind power depends on the amount of air, velocity, and the mass. And the total power generated from wind energy is directly proportional to cube of the velocity, air density, and swept area, this rotor diameter and area basically. And efficiency of any wind turbine is maximum can be achieved 59.3% as per the Bed's limit. So any turbine, any modern turbine which is right now designed, it cannot go beyond 59.3% efficiency because of this Bed's limit constraint. Same if we talk about this capacity factor and power curve. So power curve basically defines or tells about how this wind turbine generates power, at what wind speed, how much power it generates. So it defines cut-in wind speed, rated wind speed, and cut-out wind speed, and how much power it is going to deliver during those wind speed things. So you can look at here the graph. Same, it depends on the frequency of wind distribution also. So typical for any wind farm, 30% is a typical, you can say, capacity factor which can be achieved from modern wind turbines. So I'm just telling you, this is an average number. It could be 20 also, it could be 40 also, but 30% is considered good capacity factor for any wind project. 30% yearly capacity factor. And lift and drag forces, these are the two important terminology, or you can say forces which drives or rotates this wind turbine. So these are the overall basics which normally people used to refer who all are working in this wind industry. So they should know about this basic thing. So that's why I highlighted this here. If we talk about the wind turbine types, so there are basically two types of wind turbine. One is a horizontal axis, second is a vertical axis. So most of the commercial turbines or multi-megawatt turbines, which you can see are horizontal axis turbine. So horizontal axis, single blade, two blade, three blade, and multi-blade turbines are there. So three-blade turbine is quite popular now globally because of various advantage. Then upwind and downwind turbines are there. Upwind turbines are quite popular. Then direct drive and gear turbines are there. So for multi-megawatt turbine now, this direct drive turbines are quite popular. Is if you talk about 3 megawatt plus, so most of the people are going, most of the companies are basically going for direct drive turbines because of it requires less maintenance compared to gearbox turbines. Same on tower front, there are multiple type of tower: lattice tower, hybrid tower, tubular tower, and concrete tower is also there. So these are the basically these all things comes under this horizontal axis segment. We talk about the vertical axis segment. So mostly these turbines are used for small scale applications, and it's becoming popular. But in India, it is not so popular so far. And in vertical, you can say there are two types of turbines categorized. One which is called as Darius type or egg type. You can look at here on this picture. And this second is this one, which is Savonius type. Now, if we talk about this wind turbine subsystem, so winds, it's basically categorized in three stages. One is the aerodynamic stage, where wind actually getting transferring its kinetic energy through blade to various part for converting into mechanical energy. Second one is mechanical stage, where gearboxes are basically coming into picture and transferring this kinetic energy into mechanical energy. And then third is the electrical stage, where this mechanical energy is getting converted into electrical energy through a generator. And then control systems will be there under this, and then load and grid, things are there. These are the three typical stages of wind turbine subsystem. If you talk about this gear turbine, so mostly, these are the major components comes under that. So here, low speed shaft, gearbox, and high speed shaft. These are the components which are, part of this gear turbine, apart from normal, other things. And in gearless, these three things are basically removed: high speed gear shaft, low speed shaft, and gearboxes. And generator is directly coupled with rotor. So here it is direct drive turbine. Here you can look at generator is directly actually driven by this rotor without any gear technology. And it is basically synchronous generators are there. And rest of the other things are similar like gear turbines. So typically, if you ask in any wind turbine, on an average, 8,000 different components are being actually used. 8,000. So electrical, mechanical, aerodynamics, instrumentation, civil engineering. So all, if you ask about any engineering discipline, so you will be getting implementation in this, wind turbine projects of all engineering disciplines. Things like gearboxes, here mechanical things are involved, generator, yaw system, pitch system, power converter, electrical transformer, brake system, main shaft, mechanical, rotor bearing, hub, rotor plates, aerodynamics, tower. So multiple things are there. So you can imagine one, uh, best utilization of engineering, into this wind turbine vertical. If you talk about this foundations are for onshore. Shallow type and mat type foundation is quite popular for plain and hilly area. You can look at here in picture also, shallow and mat type foundation. And for rib type foundation is also becoming popular nowadays. And pile type foundations are there, which is used for soft earth area, marsh area, is during in nearby coastal regions. Then uplift anchor type foundations are basically used in mountain areas. And then new modern American type foundation are also becoming popular, which are used for various which are used in various areas. If you talk about this offshore foundation, monopile, tripod, floating, this type of foundations are there. If we talk electric, now we'll be touching this electrical generator system. Actually, I am touching this all slides very fast because we have to cover almost 34 slides. So 1 hour will be, I think, short. That's why I'm covering this faster. Is it okay? Hello?
Yes, sir. Yes, sir.
Yeah. So type of generators, type 1 like conventional induction generator and variable rotor resistance type induction generators. These are type 1 and type 2 generators are the old generators which were used in old turbines. Now in modern turbines, doubly fed asynchronous generator and full converter units, which could be used in synchronous and induction both type of generator, are quite popular. So type 3 and type 4 means doubly feed induction generator and synchronous generator, full type converter generators are quite popular nowadays in wind turbines. We talk about the control system. Control system for blade regulation, control, stall control, active control systems are there. So pitch control and active stall is quite popular because if you can look at here from cut in wind speed to rated wind speed, these all control systems are working okay. But after rated wind speed to cutout wind speed, stall controls are power is getting degraded if you are using stall control generators. So in active stall, these all things have been compensated and it is giving better power performance, active power basically from rated to cutout wind speed. So that's why modern turbines are either using pitch control system or active stall control system for controlling this power. In grid integration side, it's like turbines are whatever power it is generating at 600 to 650 volt. That power is getting step up at unit transformer at 33 kV or 22 kV level. Here you can look at, and these 33 kV lines are getting connected to this pooling substation or collector substation and getting further transform into 66 kV or 132 kV based on the system availability, grid availability. So these modern turbines are basically, it can be integrated at micro level for any microgrid applications. Also this can be used for city level power supply. Also this can be used for regional level power supply, and for national and transnational level also, it can supply power. These are the basic layout of grid integration. I'll just show you one video. Is it visible now? Can you look at this video?
Yes, sir.
Yeah.
Yes,
So,
sir.
this will summarize whatever things so far we have covered. So it will give you how the wind turbines works. So it's a small video is there. So it will show you how the wind turbine works. Okay.
You've probably seen a wind farm, but do you know how wind force is converted into electrical energy? We are going to show you how a wind turbine works. Each wind turbine has a wind vane at the top that indicates the wind direction. This allows the turbine to rotate on the tower and face the wind. The blades also rotate on their axis for maximum resistance. That is, the kinetic energy contained in moving air currents spins the blade. These are designed to fully capture its energy. They can be as long as 60 meters each and are made of very light and resistant materials for ease of movement. Even with very light winds, starting from about 11 kilometers per hour. With very strong winds, above 90 kilometers per hour, the blades are placed in the feathered position and the turbine stops spinning for safety reasons. The blades are attached to the wind turbine through the hub, which is coupled to the low-speed shaft. The low-speed shaft is given this name because it spins at the same speed as the blades, between 7 and 12 revolutions per minute. To produce electricity, it is necessary to increase the turning speed of the low-speed shaft. The mission of the gearbox, which raises the speed over 100 times and transfers it to the high-speed shaft. The high-speed shaft, that rotates at up to 1500 revolutions per minute, is connected to a generator. The generator converts the kinetic energy into electricity, a source of energy that is easier to transport and use. Electricity produced in the generator is conducted through the interior of the tower to the base. There, the transformer raises the voltage for transport inside the wind farm. From each turbine, alternating current is sent to the substation through underground cables. Here, the voltage is increased again to feed it into the power grid and transport it to end consumers. This is how we use the wind to light cities, feed industries, schools, or hospitals, or operate our household appliances in a clean and sustainable way.
Yeah, I believe we will have got some overview about this system after this video also. So now we'll be covering wind project development and execution side of this presentation. So in wind project development and execution phase, key activities starts from land acquisition, infrastructure development, equipment and accessories supplies, erection and commissioning, power evacuation, comprehensive winder agreement, licensing, and financing of this project. So in project life cycle, if you talk about, it starts from promotion, then design, construction. During this stage, wind turbine selections and supply happens. Then after startup and operation, then wind down and then dismantling. So in each phases, like in promotion, site selection, mid tower installation, wind data gathering, micro siting, these things, people used to do. Same for design. In design phase, engineering, permits initiation, environment impact assessment. In India, it is not required, but globally in other countries, it is required. Because in India, this for wind energy, renewable energy and wind energy, government has MOEF has given this as a white category. So this studies not need to. Or same for access and connection approval, grid connection approval, things also comes under this phase. Then EPC agreement, then contract closure, then during construction, engineering, and construction works happens, power supply startup. Then during wind-down operation, technical, administration, management, these all things comes under this phase. Dismantling or repowering also one new thing has come up here, and lifetime extension also comes here. So that will come after operation and maintenance. Now for wind resource assessment, if we talk, so under wind resource assessment, this identification of wind-rich sites, this is the first step which needs to be done. Then installation of MetMast wind data monitoring system will be there. Then wind data analysis will come. Then after micrositing where turbine needs to be put in those identified area. So that will come under micrositing. And then load analysis. What is a load on wind? Like what is the class of site and what is the class of turbine? So those should match. So like class that will be done in load analysis. So clearance or permit wise, pollution control code approval, then forest environment approval, transmission state nodal agency, NOC, then statutory clearances from municipal corporation, defense if it is applicable, civil aviation if it is applicable, then for interstate power transfer, stage 1 and stage 2 connectivities also is also needed. Wind project execution wise, if we talk the first stage, actually during execution is access road. So the first this roads needs to be built from nearby state highway or national highway to the specific location or site. Then second, then power evacuation substation, how this power will be evacuated, so that substation works get started to evacuate power. Then third stage would be civil foundation of turbines. So as per the micrositing, whichever has been finalized, where in those micrositing locations, civil foundation and civil works will start. Thereafter, equipment, transportation, logistic part will come into picture. So you might be aware, like blade is one of the critical or one of the long length equipment is there. So logistic point of view, this road needs to be widened if it is on hilly area. So this road work and this blade transportation is very important. That needs to be taken care during this transportation works. So almost in India, why we are not going for higher multi-megawatt turbine? Because of this, transportation and logistic is one of the key issue. Like other countries, they are going for 5 megawatt, 10 megawatt because they have that much of infrastructure. But in India, we are lagging that, and because of that, so far we are not crossing 3 megawatt turbines. Because of this is one of the critical issue we are facing. Same turbine assembly, it means after this equipment transfer, when equipment will reach to the site, then turbine assembly will start. So here, cranes, those all things will be placed here, and then one by one, erection work will start. This is a tower erection. Then after tower erection, nacelle erection will start here. nacelle and hub assembly. These all things are lifted at very high height, up to 100, 120, 130 meters from ground level. Then this blade erection will start after this hub erection. And this is a final turbine installation. These are, and after installation, substation will be charged, and then commissioning the turbine will happen. These are the process involved into wind project execution. I'll share one small video here.
सर कुछ आवाज नहीं आ रही है.
Just 1 minute. Yeah. Whatever things I spoken, so there is one video. So I'm thinking to share that video. It's installation and erection process. Look at here. Is it now? You can look at.
Yes, sir. It is visible.
Yeah. It's a 1.5 megawatt wind turbine erection process. Like this is the civil work. After that, the foundation. This is the toughest, bottom section erection is happening here. Mostly in erection, actually mechanical people involvement will be more. Mechanical engineers actually play a very important role in turbine erection. This is the second section. So this is a nacelle lifting. This is nacelle is now placed on copper tower. Now blades are connected with hub. Blade is now getting connected with hub. Now this third blade is getting connected with hub. Now this top is getting lifted. Two types of cranes are used here. One is the main crane, one is the supporting crane. So you can look at here. Now hub is connecting with this nacelle. So this is the overall. This is overall installation activity. You know what I did in last session. So actually, on ground, this type of things are happening. So I just shared this to visualize whatever things I was telling. So you know, students can visualize that in practical way. So hope so far, how's the thing? Like, is there any question you have so far in last two topics? Hello, can you hear?
Yes, sir.
Is there any question? Is there like anyone have any question?
If the participants have any question, they may ask. They may unmute themselves and ask.
Or we can do one thing. Let me finish that, and in last we can take up. Okay, you
Yeah,
can
that
write
will-
your questions. You know.
Yeah, that will be better.
Yeah. Then in last we can take up that.
Yeah. Okay.
Okay. So now we'll be going to this Random and asset management part. So after turbine gets installed and get commissions, then operation maintenance will start. So till operation maintenance, whatever things are happening, this is happening just for making things ready. So after that turbine is installed, then only it will produce yield and giving generation to the grid. So this is one of the critical things, the operation maintenance and asset management for any project, any wind, solar, or any infrastructure project, because the actual yield will be given during this operation phase only. So whatever seed we have sown so far, in terms of turbine installation, so that will give you result during this phase, operation and asset management phase. So this is very critical phase for any infrastructure project. So the practices for operation maintenance now, best practices needs to be developed so that assets are maintained in best suitable way. So for that, SCADA system is also now connected with most of the modern turbines. So online, by sitting anywhere in the world, you can see what is happening inside turbines, which system is performing how. So you can virtually connect to the turbines and talk also with turbines. So in wind-up activities, maintenance are basically categorized in two type of maintenance. One is a preventive maintenance, and one is a predictive maintenance. Preventive maintenance is basically carried out, as per the base plans, quarterly, monthly, yearly. So whatever the schedule is there as per the particular equipment-wise preventive maintenance activities needs to be carried out. For predictive maintenance, is basically done to detect failure before it happens. So here, lots of automations, artificial intelligence, big data analysis, those things are playing very important role for this predictive maintenance. And according to predictive maintenance, corrective actions needs to be taken. So for maintenance wise, you can see here various plans is like activity plans needs to be looked into, inspection plans needs to be looked into, periodicity, 6 month, annual, biannual, triannual, based on the component, which component, like as I told, around 8,000 components are there. So which component needs to be given specific maintenance at what interval. So those things as per the SOP needs to be carried out during that period. Same repair and inspection activities, safety related things are also need to be looked into. So like adjustment, repairing analysis, cleaning, lubrication, these all things comes under preventive maintenance. In predictive maintenance, there are major components, whichever are high value items like turbine, generator, like gearbox. These are the high cost items. So for that, predictive maintenance is very much needed, and with various, by using various sensors, IoT devices, this asset manager or asset management people are looking vibrations and temperature, and if it is going beyond threshold limits, they are immediately attending those particular turbine and taking corrective action to minimize any severe downtime. So on asset management part, key objective of asset management is to reduce downtime, reduce operating expense, improve revenues, and extending life of asset. Here for asset, we are referring wind turbines. And the role of asset manager here will be production performance monitoring, risk register and mitigation, health, safety, and environment aspect needs to be looked into. financial management, stakeholder relationship, regulatory compliances, contract management, and planning, records, and reporting. So these are the key roles of asset management. The owner who is owning turbines, he used to have one asset manager or team of asset managers who will be doing these all things on regular basis. Then stakeholder wise, for any, this asset manager have to manage power purchaser who will be purchasing power. So wind turbine, normally it is purchased by distribution companies, state government companies, or some private companies also are there. So those are the stakeholders which comes under this power purchaser. Then landowners, then operation maintenance contractor, and government bodies, investors and lenders, network operator, and local communities. So this asset manager has to manage these all stakeholders also. So this is a operation maintenance and asset management part. So most of the long term, you can say, like these turbines are installed for 20 to 25 years life. So the asset management and this operation maintenance contractor role is very crucial. We will be there for at least 20 to 25 years of life for every individual turbines. And they have to carry out these all things. Now we'll be going to this wind potential topic. What is the wind potential in India? So onshore wind potential in India at 100-meter height is around 302 gigawatt, as Mithlesh already told earlier. So mainly these are spread in 8 states so far. So not this, so right now wherever construction and installation activities are happening, these are concentrated on this 8 states. So Gujarat is having around 84,000 megawatt of potential at 100 meter. If you go to 120 meter height, then number will be increasing. So like here I have mentioned, Neve had earlier done an estimation at 50 meter around 48 gigawatt till 2005-7 when I joined this industry. That time people used to say ki maximum potential of wind in India is 48 gigawatt of 48,000 megawatt. So that was actually estimated at 50 meter height. After that, this 80 meter came. So then people told me it is 100 gigawatt. Now 100 meter height turbines are there. So now it is estimated around 302 gigawatt. Now 120 also came up. So around 600 gigawatt is new numbers what is coming up. But there are some other agencies also, Lawrence Berkeley Lab and other agencies, who are telling at 120 and 3% of wasteland, 120 meter height and 3% of wasteland even will be used for wind power generation. Then also India is having more than 2,000 gigawatt of wind potential onshore. Okay, so like here in North India, this Jammu Kashmir, so far we have not tapped anything. Here also wind potential is very good, but so far this area is not tapped, for installation of wind power plant. So there are many virgin states in India which also needs to be active. And even at 100 meter right now, we are using only 12% of total utilization so far happened. So there is still adding from 38 gigawatt, 27.5 gigawatt. Still we have to reach a long way. We have to go long way. Offshore wise, many like studies are being conducted by various agencies. So this is a number of this is a estimation given by this World Bank, which says around in India total potential of technical potential of offshore wind is around 195 gigawatt. Out of that, 112 is fixed fixed type, and 83 gigawatt is for floating. Area which they have identified so far is Bhuj area in Gujarat, then here in Andhra Pradesh, this is nearby Visakhapatnam, and then in Tamil Nadu nearby Tuticorin. So these three regions so far they have done a study, and they found around 195 gigawatt can be explored and generated from these areas. And now we'll be looking what is the wind power status at present. So we'll be covering global, what all things so far happened since 1982. Why since 1982? Because in that year, actually, first 3-bladed wind turbine of 22 kilowatt was installed. And this European Wind Energy Association, Europe is basically, you can say, is hub for wind industry or wind industry promotion also. So many, like Denmark, Germany, so many wind turbines companies are from Europe only, or technology provider, you can say. So in 1982, this European Wind Energy Association was formed, and thereafter in 1991, first offshore wind, was actually in Denmark installed. Denmark is one of the pioneers in offshore wind also. In 2001, this more than 1 megawatt of average onshore wind turbine, started. And then 2005, Global Wind Energy Council was established. 2008. In 2008, actually, total wind power globally reached to around 100 gigawatt. In 2008 itself, 100 gigawatt number. Then more than 1 million people were working into this sector. 2014. Then at present, if you look at around 10 megawatts single commercial turbine is available, offshore turbine is available right now. So these are the major milestones, globally so far in wind sector has been achieved. You talk about India. In 1991, this private power purchase policy came into this picture. 1993, this MNES, Ministry of New Energy Source, which is now MNRE, they came up with policy and guidelines for tariff determination. Then in 1994, for wind power production, accelerated depreciation was introduced, which were at that point of time 100%. Like if you are investing 100% money, so you can claim 100% tax depreciation against that investment. In 1996, this National Wind Resource Monitoring Demonstration Program started. Then in 1999, CWIT was established, which is now called NIWE, National Institute of Wind Energy. Earlier it was named Center for Wind Energy Technology. So that was established in 1999. Then after, in 2002, this accelerated depreciation from 100%, it has been revised to 80%. And in 2003, Electricity Act came, and this FIT provision also started after feed-in tariff mechanism. So this so far in India, we are still using or we are guided by the principle of Electricity Act 2003. Now, Electricity Act 2020 is also work is going on that. It will take, I think, more time. Then National Electricity Policy came in 2005. Then RPO in tariff policy was declared RPO is a renewable purchase obligations. Why people are purchasing this renewable power if there is no guidelines or there is no incentive or penalty to purchase this renewable power, then nobody will purchase. So government has actually created one framework for RPO in 2006 as per the electricity tariff policy, 2006, and which were mandated to every discount to have certain power, certain portion of renewable power in their power portfolio. Then in 2009, this GBI came into picture, generation-based incentive to promote wind industry. So as per generation, whatever generation you will be feeding to grid, government means Ministry of MNRE was giving 50 paisa per unit additional on your existing tariff under this scheme, which was channelized through IRIDA. Then renewable energy certificate regime came into picture in 2010. So to meet the RPO, any entity who is obligated to have fulfill certain RPO, they can purchase if they are not purchasing renewable power or if they are not generating renewable power also for captive, they can purchase some certificate to show themselves as a green company under this RC regime. And then AD and GBI discontinued in 2012, and installation also decreased. You can look at here during that period has reduced to less than 1500 megawatt. Then it was reintroduced in 2014. There are
Just 1 or 2 minutes. Our speaker will rejoin us. There is some technical issue with the network of the speaker, so he will rejoin us.
I request everyone to be in the meeting. He will join soon. Please wait for 5 minutes. He is joining. Am I audible to everyone?
Yes, ma'am.
Yes.
Yes,
He is joining. All the participants are requested to please wait. There was some network issue. Mitlesh, your voice is not audible. You are saying something.
Yes, ma'am.
आप कुछ कह रहे हो क्या? कुछ audible नहीं है अभी.
No, ma'am.
अच्छा अच्छा ठीक है. If participants you are having any questions, so just put it in the chat box. He will revert you back.
Hello. Is it audible?
Yes, sir.
Yes, sir. Yes, sir.
Yeah, sorry, actually, this Wi-Fi got disconnected.
Okay, no problem, sir.
All of a sudden, this
So,
power went off and then Wi-Fi got disconnected. So I am just, so from where we were there, uh, just 1 minute. Uh, okay, so we were on which slide? Slide number. We had covered this slide, this turbine technology. Hello.
Yes, sir.
Yeah. So this, we were on turbine technology evolution. Na?
Yes, sir. We were on this slide only.
This slide only. Na?
Yes, sir.
Yeah. So in 1980s to 90s, actually average turbine size was around 75 kilowatt, and the height was around 17 meter. So from 1990s to now in 2020, the average size of wind turbine globally is around 5 megawatt, and the average height is around now 125 megawatt. So now we in next coming few years will be somewhere around 10 megawatt average size and 150 megawatt 150 meter hub height. You can see, as the year passing on, the turbine rotor diameter is increasing, rating power is increasing, hub height is increasing. So we are going to capture more energy, from wind through this technology evolution. And over next few years, maybe we will be having single turbines of 20 megawatt also. So at present, the maximum, offshore wind turbine which is available, or so far in the which is available in the world is around 12 megawatt, which is recently launched by GE, and this hub height is around 260 meter. 260 meter hub height. It's a very huge turbine, and 220 meter rotor diameter. So almost 110 meter single blade. You can imagine, that much of bigger turbine already prototype is there for offshore application, which is developed by General Electric. And MHI Vestos, they are already offering one V164, which is around 9.5 to 10 megawatt turbine of 140 meter hub height, and it is available for commercial application. And in Europe, in certain countries already they have offered these turbines for offshore installation. If we talk about this onshore, so Enercon E126, which is around 7.5 to 8 megawatt turbine, already it is there for onshore application. So this type of technology evolution is happening in wind energy sector. So now we'll be looking wind power status. So in 2009, average yearly installation was around 38 gigawatt, and that time around 159 total worldwide wind power, 159 gigawatt was installed, which is at present is around 650 gigawatt. So in 2019 total globally total wind power installation is around 651 gigawatt, which is I think more than solar at present, and solar is very near. Hopefully in coming days solar will be crossing this, but wind and solar will remain neck to neck over the period of time, installation capacity wise. So in India, like here, this is a graph which is actually I have got from REN21 from Global Status Report. So for India, around last year, 2.4 gigawatt plus installation happened in India, and total installation is around 37 gigawatt. China is huge; it's almost 225 to 30 gigawatt already in China it is installed. So China is one of the largest, you can say, wind power country in the world, in manufacturing wise as well as installation wise. And second is United States, which is around 100 gigawatt. And India is, I think, Germany and US are there, and then India is actually fourth largest. Yeah. And which are the bottlenecks of wind energy growth so far? Key bottlenecks are just I mentioned here. So land and power evacuation infrastructure availability are the key concern for the sector. Transmission infrastructure availability. DISCOM financial health, this is one of the major bottleneck. Lots of payment delays are happening, especially in MP. If you look at almost 1 year delays there. So from generators are not getting paid from last 1 year for whatever the power they have sold to distribution companies. So market design, reverse bidding transition is also, so far it was considered as one of the impediments because it is designed for certain class of investors, big investors basically. For medium and small SME, they are not able to compete in this regime. This was also one of the impediments. Then lack of regional cooperation, state, interstate, policy things were different, rules regulation were different. So if somebody wants power in different state and he has power plant in another state, charges, losses were very high to transmit those powers. So those are one of key bottlenecks. But government is addressing these all things, and hopefully in coming future, these things will be addressed properly and as per the prediction, whatever things are there, will be able to achieve. Employment status in renewable energy overall globally is around 10 million people are there who are employed in this sector. And in wind energy specifically, if you talk, around 1 million people are working globally. In India, around, you can say, 58,000 people are working in this sector. So as you know, right now total installation is around 37 to 38 gigawatt. As this installation will increase, so number of employment also will be increasing globally as well as in India for all technologies. There is a good opportunities, for employment point of view. Going forward, this new capacity addition for power generation will be mostly into this renewable energy sector, solar, wind, biomass, hydro. So these technologies are going to play a very important role over the period of time. And so there is a good opportunity for everyone, especially for electrical, mechanical, civil engineers, electronics, instrumentation, chemical. So all discipline, computer science, IT, IoT, are playing very important role into this. So for all engineers, this could be one of the good area for career point of view. People can look at this for long-term employment wise opportunity. This as an opportunity. Innovation and what all innovations are happening. We talk about performance improvement wise, capacity wise, higher turbines are coming up as we seen in previous slides. Large rotor blades are coming up. Material wise, superconducting magnets are, research is happening into that segment. Capacity factor wise, higher height is giving, better capacity factor. Advanced control methods, pitch, blade system, these things are, happening. Cost wise, people are mostly working on weight reduction. Two-blade design concept is also being developed in certain areas. Direct drive systems are getting popular, to reduce gearbox and drivetrain And offshore wind may to reduce cost, foundation work is happening in foundation, construction and maintenance, means construction and maintenance aspect wise. For reliability and availability, like wind is not firm, 2 or 24/7. So to make it firm, lots of forecasting things are happening. Storage is also being explored, to make it more reliable. So here, big data analysis, analytics are playing very important role in for making it more reliable. And then advanced control methods, material wise, direct drive, removal of gearbox. Already we have seen that. Design may floating, direct drive, high altitude concept. These things are now getting popular. Grid side integration, demand side management. These things are happening. Storage, if you look at batteries, pump hydro is getting popular now. Battery is one of the major things. India, everyone is talking about batteries, lithium ion, not only for renewable storage, but for transport sector also. Hydrogen is something which is very much right now also, getting popular, especially in Europe. So people are using this wind power to generate hydrogen through electrolysis, process. So that is also going to be quite popular. Maybe by 2030, this hydrogen power also will be quite popular in India also. Battery, hydrogen power, for storage, these are going to play a very important role. Vehicle to grid, these things are also coming up. So this is also going to play a very important role over the period of time. Lots of innovations and developments are happening, and means there is a scope for everyone in this sector, and these all are interrelated, which is a good thing. So yearly WTG additions, as most of the people you'll be aware, like 60 gigawatt government is planning by 2022. So as per GWEC forecast, right now around we have 37 to 38 gigawatt. So from here reaching 60 gigawatt will be very challenging, considering various constraints. So it is expected we may hit, if we go with high case scenario, we may hit somewhere around 54 gigawatt by 2022. And if we really want to hit 60 gigawatts, so per year installation means, this number has to increase. Right now around 12 gigawatt already tendered out. Even with that, we'll be able to achieve 50 gigawatts. So as 10 gigawatt tendering still have to be done. This all process needs to be, improved and be faster to achieve this target. And the good thing is installation base for wind. Right now we are somewhere around 37 gigawatt, and as per the CEA, they have forecasted India's renewable energy need for 2030, which is expected to be around 450 gigawatt, including solar. So wind and solar all together will be around 450 gigawatt by 2030, which is at present around 80 gigawatt. So wind will be around 140 gigawatt. So there is a good growth. Almost 13% year on average is required to achieve that target. So this is a way forward, and this is a sustainable opportunity for everyone. So design, R&D, construction, O&M, asset management. So these are the areas where the people can look at your career opportunities. And I would say you'll also feel proud, because this is something where you are contributing to your society also, your nation also, and this is sustainable, and it's a win-win situation for everyone. So thank you everyone. Now, whatever queries you can ask.
Thank you, sir, for such a wonderful and knowledgeable session. Participants can unmute themselves to ask any queries. Participants, please unmute themselves to ask any queries.
Mitlesh, the questions are available in chat box. So you just read out the questions.
Okay.
Acha, one question is there: what is the minimum cost is required to make one wind turbine? So see, big turbine means I just give you megawatt basis. So for 1 megawatt on an average, the cost will be around 5 to 6 crore if you are looking for 1 megawatt wind turbine installation. So including everything, the land, turbine, grid, so altogether around 5 to 6 crore.
Sir, Abhishek Roy wants to ask that you have said that every type of engineer is required for the project regarding that wind turbine. How CSE is involved? Computer science engineering.
Computer science engineering, actually, as I told you, so lots of things are happening in IoT and big data, AI, and on AI aspects. So there, computer science engineers can play a very important role, especially to make this system automated, more communicable, and already many computer science engineers are working in this field. SCADA is one of the area where already people are working. So it's open for all all engineers. So electrical, computer science, IT, anyone can join this industry.
Dipanshu Kumar want to ask that can we use the horizontal blades?
Horizontal axis turbine you are talking? Yes. Horizontal means it's a horizontal axis turbines are basically used right now. So horizontal blades means the blades are whichever blades shaft is there, so that is horizontally axis, that is called horizontal axis turbine. Mostly horizontal axis turbines are being used in modern wind turbine design.
There is one more question.
It's axis, it's horizontal axis. Like this is a horizontal. Blades are connected with this axis. These are called horizontal axis turbine. Vertical axis means axis will be like this. Okay.
Yes, sir.
Hope you understood.
Sir, what is minimum velocity required to set a wind turbine?
Minimum velocity is called cut-in wind speed. Okay, so which is around 2 to 3 meter per second based on the design. So modern wind turbines, if you look at around, it starts from 2 meter per second as per the power curve, and it will give you rated capacity. If suppose it is designed for for example, 1 megawatt. So at 3 meter or 2 meter per second, it will not give you 100% 1 megawatt, but it will give you just one.
Sir, is it possible to set up wind turbine in any area?
Any area, no. Minimum you require 6 meter per second yearly average wind speed. To install wind turbines for commercial purpose to make some profit out of that. If it is less than that, then it will not be making economical sense. So average wind speed, if you ask yearly average wind speed for any economic point of view is around 6 meter per second, which is very much needed, for installing any wind turbine. Minimum, it's class 3 sites I'm just talking. If it is a class 2, it will be more than 8 meter per second. Class 1 will be more than 9 meter per second. Like that.
Sir, there is one more question in chat box that is it suitable for big cities? Installation is suitable for big cities.
Big cities, see, suitable means yes. Now people are coming up with new, innovations where they are putting this type of turbines on uh, top of the buildings also, or during the construction phase, like you have seen in Dubai. The twin tower is there where they have used, wind turbines also, and connected this wind turbines and created tunnel effect to have maximum wind speed. So it's a possible, and people are doing also. In Europe, you can find in cities also wind turbines are there. But the thing is, here the challenge would be if suppose you are installing this in cities, and if suppose today you are installing, maybe after 5 years some big tower comes, in prevalent direction of wind, then it will create obstruction for this turbine. So the generation will, after that will be reducing. So that's why people don't prefer to put anywhere this. So they look at okay, wherever they are putting, at least in that area, next 20 to 30 years, there will not be any obstruction. So that sort of a study needs to be conducted before putting any turbine. But it's a huge investment, 5 to 6 crore per megawatt investment you are putting, and if suppose after certain period some obstruction comes into this picture and it blocks wind speed, then your generation, whatever you estimated, it is not coming, so it will not be viable. Yes.
Can we apply it?
Yeah. And
sir, there is a question that how can we apply for a job in this area?
So now, see, there are multiple areas, as I told you. So based on your interest, you can go for certain, study also, and you can choose certain companies where you are interested to, you are interested to join, and you can, contact them. You can send your CV to HR, and they may definitely consider you, because now many MNCs are coming up as a developer, as a IPP, so and they need new people, young people in their workforce for design, engineering, construction, wind-up, asset management. So there is a huge scope. So first you look at what exactly, in which stream you wanted to go. Like computer science people, if they wanted to go into, analytics or some coding, some big data or supercomputing, so that sort of things are also here. So they may, look at those aspects, do some courses, and then apply to relevant company. They will definitely, consider it.
Sir, it is the last question. Is the system is noisy? Is the system is noisy, and which material is used to make the turbine blades?
The FRP is generally used for making turbine blade. So if the system is noisy, means, see, there is a regulation this turbine should not produce more than certain decibel of noise. So on an average, I think 104 decibel is permissible right now. So if it is less than that, so it's okay. It will not create too much of noise. And material wise, carbon fiber and fibers are basically used for this blade, design.
Thank you, sir.
Yeah.
The participant, the link for the feedback form is posted on the chat box. All the participants are requested to give their valuable feedback regarding the session. The certificate will be sent to you through the registered mail ID. Now at last, I would like to invite Professor Neha Srivastav, HOD EC and EX, and coordinator of this event, to proceed. Vote of thanks.
Thank you, Mithilesh. Good afternoon, everyone. As all good things come to an end in life, so is this webinar. On behalf of Department of Electrical and Electronics Engineering of TRUBA Institute of Engineering and Information Technology, I, Neha Srivastav, coordinator of today's event, take this opportunity to propose vote of thanks to the resource person, Mr. Manoj Singh, for delivering such a wonderful session. We are really enlightened with your knowledge and presence, sir. I am highly thankful to Dr. S.T. Chobe, coordinator TEQIP-III RGPV Bhopal, for giving us an opportunity to organize this session. I would also like to thank our chairman, Sri Shyam Rathore sir, for his continuous motivation. I would like to convey my sincere thanks to our director, Dr. Rajiv Arya sir, for his enthusiastic support and guidance. I am also thankful to those who have directly and indirectly contributed to this webinar, WIN, a step towards sustainable energy for future generations, organized by our institute. A special thanks to the organizing committee, teaching and non-teaching staff for their unflinching support and coordination. My heartfelt thanks to our students for active participation. With these warm words and a kind message, we move to the end of today's webinar. Thank you. Thank you, everyone.
Yeah, thank you, everyone. Hope you people have enjoyed out of this session. And
Yes, sir.
Yes, sir. Yes, sir.
Out of
Definitely.
55, at least 5 will be, after your graduation, will be somewhere working in this industry, renewable industry. Good. Yeah. Thank you. Thank you so much.
Okay, sir.
Thank you, sir.